Jishnupriya Nampalli, your mic is not working, but you can enter with ID number. I know very well you are able to hear me, although your mic is, you are unable to give answer to me, but you are able to hear me. As you are able to hear me, come with ID number. I am removing you now. So if they can't hear me, then what is the purpose of attending deaf and dumb class? Correct now? Is of no use. टाइम इज 11:20. आराम से खा के पी के वलीमे में जाके, शादियों में जाके खा पी के अभी हम लोग आ रहे हैं. नाउ वी आर कमिंग 11:20 एंटरिंग. Any doubt in test portion? I am waiting since 5 minutes, not 1 minute. Exactly at 11:14, I have logged in. 11:14. Time is 8 minutes. Since 8 minutes, I am waiting. Chalo, no doubt you're asking. When no doubt you're asking, I won't waste time, because clearly I told you that first I'll give you the buffer time, and in buffer time you have to ask. You are not asking. So as I told you, I won't simply say read yourself. No, because when test portion I have completed last week only, not this week, last week. So when 1 week before only test portion has been completed, I am not having that much energy or the patience to again give you time to go on reading. You will simply kill your time. You will simply kill your time. And you are famous for that. You are famous for killing time, most of you. Now, coming for the next point. Next point is a derivation. So what is new point? 7th point, 8th point? Sixth point. So now I'll go for the point number 6. Now I'll go for the point number 6. Point number 6, I'll go for derivation. And derivation is exactly the same derivation it is there, what I have given you in topic elevation in boiling point. Just on the place of the B, here I am writing what? F it is there. Now go on copying from blackboard. This means we know delta TB is directly proportional to change in pressure. It is there. This we know. This we know from where? From graph. MF. From curve, we know delta P is directly proportional to mole fraction of solute. This we know from Raoult's law. This we know from Raoult's law. This we know from the curve. This we know from the water. Raoult's law. It is there. Keeping this in the mind, it's very clear that whatever delta TF it is there, it is directly proportional to mole fraction of the solute. So if I'm removing this proportionality, I'll keep some proportionality constant, and this proportionality constant is something K, and this is nothing but mole fraction of solute. Now, like yesterday, I won't go for detail because yesterday I have given to you. So now I'll straight away write that delta TF is equal to K. On the place of solute, I will write W by M into 1 divided by weight in terms of the kg. It is there. Weight in terms of the kg. It is there. Weight in terms of the kg. Weight in terms of the. Can I go for this formula? Weight in terms of the kg?
Yes, sir.
Now I'll go in this way. Yesterday I have given to you. K is a constant. M is a molecular mass of a solvent. So K into M is equal to new constant, and this new constant is called as a Kf. This new constant is called as a Kf. So this is becoming delta Tf is equal to Kf. Here no change, W by M, it is 1 by kg. If I am writing this in another form, this is becoming delta TF is equal to KF into W by M into 1000 divided by W. It is there, and this is there in terms of the grams, a very famous formula. Already we are having a very clear idea, whatever M it is there. Whatever this M it is there, M is equal to W by M into 1000 divided by W. M is equal to W by M into 1000. Some shameless members, 4 or 5 shameless members have entered after 10 minutes. And if I'll ask them, they'll say connectivity issue problem was there. W by M into 1000 by W, it is molarity. Delta TF is equal to KF into M. So this one and this one are the very two famous formulas are there. Very two famous formulas. When I started the class, at that time strength was 55. Now strength 73. Imagine how many members are late. Before my class, you're having any class? No. Am I correct?
We had, sir.
We had botany.
Huh?
What is your class?
Botany.
Anyone doubt in this one?
No, sir.
This is the same thing which I have repeated yesterday. Same thing which I have repeated yesterday. Now, coming for the point number 7. Point number 7 is this point I want to give. This point I want to give. Yesterday I have mentioned colligative properties and the molecular mass of the solute are what? Inversely proportional. So I will write same thing here. Delta TF, which is depression in the freezing point, it is nothing but one colligative property. CP means colligative property, and this is inversely proportional to M. What is M? M is molecular mass of solute. M is molecular mass of solute. Now coming for the point number 8. Point number 8 is same KF. So yesterday I have given you KB, and now here I am going for KF. KF. Point number 8. It is also called freezing point constant. It is also called a freezing point constant. Yesterday I have mentioned boiling point constant. It is also called freezing point constant or molar depression constant. Yesterday I have given you elevation constant, molar depression constant, or yesterday I have mentioned you abelioscopic, and here I'll mention cryoscopic constant. Cryoscopic constant. So it is also called, it means KF. KF is also called as a freezing point constant. It is called as a molar depression constant, or it is called as a cryoscopic constant. If point number A completed, let me know.
Completed, sir.
Write point number B. For a given solvent, the value of KF, is independent. The value of KF is independent of nature of solute. The value of Kf is independent of nature of solute and its concentration, 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 and its concentration, and its concentration. Point number C. Point number C. Kf is a calculated thermodynamically. Kf is a calculated thermodynamically. Kf is a calculated thermodynamically. Kf is a calculated thermodynamically as Kf is equal to RTF square 1000 divided by LF. All terms are very clear. LF is nothing but, TF is nothing but freezing point of solvent. Freezing point of solvent in Kelvin. Very, very careful. Freezing point of solvent in Kelvin, because if you take in terms of 0 degrees Celsius, all terms become 0. This becomes 0, correct? So therefore, in terms of the Kelvin, means 273 Kelvin it is there. LF is nothing but latent heat of fusion. LF is nothing but latent heat of fusion. LF is nothing but latent heat of fusion. Same old thing. LF is nothing but delta HF divided by molecular mass of solvent. What is delta HF? Enthalpy. Enthalpy of fusion. So if this I am putting here, it is becoming Kf is equal to RTF square divided by 1000, and in this place I will write
Completed, sir.
Oh, very good.
1 minute, sir.
1 minute.
Freezing point of solvent in Kelvin is not ink. Freezing point of solvent ink is not ink in Kelvin.
Done, sir. Thank you.
Now coming for the last point. Last point, name is important. Its application is not important. Name is important. Name is important. And this is point number 9th or 10th?
9.
Sir. 9.
Point 9 star mark. Name is important, but I'm telling you, in the examination, based upon this numerical problem, they won't ask you. Theoretical question, as it is the statement I'm giving to you, based upon that, as it is, they will ask you. So, yesterday I have mentioned that relative lowering of the vapor pressure colligative property, how we are calculating experimentally by help of Ostwald and Walker method, not there in syllabus. Yesterday, I have taught you Landsberger method. By help of the Landsberger method, we are calculating the water elevation of the boiling point. So if Landsberger method is for the elevation of the boiling point, Ostwald and the Walker method is for the relative lowering of the vapor pressure. So definitely for the depression in the freezing point also some method it is there. So this I am now going for. Right? Depression in freezing point. depression in freezing point, depression in freezing point, depression in freezing point, depression in freezing point is calculated. Depression in freezing point is calculated. Depression in freezing point is calculated by Rast-Camphor method. Depression in freezing point is calculated by Rast-Camphor method. Rast-Camphor method. Another star point. In Rast-Camphor method, in Rast-Camphor method, in Rast-Camphor method, camphor is used as a solvent. Camphor is used as a solvent. Camphor is used as a solvent as camphor is used as a solvent as camphor is having very high value, as camphor is having very high value of Kf, as camphor is having very high value of Kf. In the bracket, right, Kf is equal to 40 Kelvin per molarity. 40 per molarity. So you got Ostwald and Walker method, you got Landsberger method, you got here Rast-Camphor method. In Rast-Camphor method, camphor is used as a solvent as its Kf value is very high. What is the value of the Kf? It is 40. In point number 8, write one point. In point number 8, D point. In this point number 8, D point, Kf of the water is equal to 1.86 Kelvin by molarity. And this value you have to remember. Yesterday I told you Kb for the water is 0.52 and Kf of the water is 1.86. These are the only two values you have to remember from the examination point of view. Only these two.
0.52.
1.86. Kb of the water is 0.52, which I have given yesterday. Kb of the water is 0.52. Kf of the water is 1.86. You compare 1.86, Kf of the water 1.86, Kf of the camphor 40. 1.86 and 40 nearby or large difference it is there?
Large difference.
And that is the reason why here I have used the word very high value of Kf, not normal value, very high value of the water. Kf, it is there. Now our third colligative property also calculate over. Now I am going for the last colligative property. So only 4 colligative properties are there. Relative lowering of the vapor pressure, elevation in the boiling point, depression in the freezing point, and now I'll go for the last one, osmotic pressure. So osmotic pressure is not new to you. Osmotic pressure you have read in botany also. You have read in the botany also. In the botany, they have not given the formula, but whatever the theory point they have given in the botany, ABCD, same theory point, again I'll repeat. Again means, again I'll repeat. Now I am going for the last colligative property, that is osmotic pressure. That is osmotic pressure. So before going for the osmotic pressure, first you have to know basic. What is basic? And basic point is osmosis. Without osmosis, you can't understand what is the osmotic pressure it is there. Let us go for understanding This is semi-permeable membrane. This is semi-permeable membrane. This is a semi-permeable membrane. It is there. And I am going for two conditions. Two conditions. Here we are having dilute solutions are there. And here we are having concentrated solutions are there. I'll go for the second conditions. I'll go for the second condition. Once I'm going for the second condition, arrow just I am keeping to give you idea. Don't think arrow both same side, arrow opposite side here, same side, opposite side is not important. What I'll tell you that is important. Pure solvent. Pure solvent. And this is solution. This is also called osmosis. 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 So what is osmosis? Flow of the solvent, not solute. Flow of the solvent from dilute solution side to concentrated solution side, or from pure solvent side to solution side through semi-permeable membrane is called as a osmosis. It's called as a osmosis. It's called as an osmosis. It is there. First you draw this diagram. Or better say diagram itself is a point number A. In osmosis, diagram is point number A.
Done, sir.
Very good. Shall I start?
Yes, sir.
Right. The spontaneous flow. The spontaneous means occurring by itself without the help of any external agency. Spontaneous means delta G is negative. Very, very careful. Very technical word I am using. The spontaneous flow of solvent molecules. The spontaneous flow of a solvent molecules from dilute solutions to concentrated solutions, from dilute solutions to concentrated solutions, from dilute solutions to concentrated solutions through semi-permeable membrane, through semi-permeable membrane is called osmosis. Is called osmosis. Is called osmosis. Is called osmosis. So whatever the point now you are writing, that is point number B. This, whatever I have given to you, it is point number B. Write or, not new point, or. The spontaneous flow of solvent, from pure solvent to solution, from pure solvent to solution through semi-permeable membrane, through semi-permeable membrane is called osmosis. Through semi-permeable membrane is called osmosis. It's called osmosis. It's called osmosis. Point number C. Point number C is a star mark. Point number C is a star mark. Right. The flow of solvent stops. The flow of solvent stops. The flow of solvent stops when both side, this side and this side, when both side will have the same value, when both side will have the same value of a free energy, when both side will have the same value of free energy, when both side will have the same value of a free energy, when both side will have the same value of free energy, and both side will have the same value of a free energy. Point number D. Point number D. Semi-permeable membranes. Semi-permeable membranes. Point number D. Semi-permeable membranes are selective membranes. Semi-permeable membranes are selective membranes. Semi-permeable membranes are selective membranes which allows only the solvent molecules to pass through. Which allows only the solvent molecules to pass through. Which allows only the solvent molecules to pass through. To pass through. Only solvent molecules to pass through it. To pass through it, comma, but does not allows solute molecules, but does not allow the solute molecules, but does not allow the solute molecules. Examples for whom? Examples for semi-permeable membrane, and whatever you know from the botany, same example I am giving to you. Examples: parchment paper, PARCH, parchment paper, comma, cellophane paper, CELLO, cellophane, PHANE, phane, cellophane paper, comma, pig's bladder, PIGS, pig's bladder is the best one. Pig's bladder, I am repeating, pig's bladder is the best one. Pig's bladder, comma, some animal membranes, and inorganic precipitate membranes, and inorganic precipitate membranes, and inorganic precipitate membranes, and inorganic precipitate membranes, inorganic precipitate membranes like cuprous ferrocyanide, cuprous, or better said, I'm saying cupric, better with cupric ferrocyanide, cupric ferrocyanide. Let us go for one solving the question based upon this Semi-permeable membrane from Akash book only. Very common question coming in the examination. Maybe same question, maybe same type of question. Very common question coming in the examination. All of you open objective 1. Akash book objective 1, question number 106. Question number 106. So first I'll tell you concept. First I'll tell you the concept of the color, and whatever the concept I'm teaching you is not new. Already this you know from your organic chemistry. This you know from your organic chemistry Lessines test. From Lessines test you know very well that when FeCl3 is combining with K4 FeCN6, you are getting blue color precipitate, or you are getting Prussian blue color, or you are getting Prussian blue color. From your Lessine test, you might have the idea what is this Prussian blue, it is there. Now going for the understanding. What is Prussian blue formula? It is there. What is the formula for the Prussian blue? Don't copy, first you understand. It is +2. It is +2. So if it is a +2, this is a -6. 1 cyanide is a -1. So therefore 6 cyanide is a minus. And therefore here I am going for the -4. Can I say?
Yes, sir.
If here I am multiplying this with this 3, can I say total charge is -12?
Yes, sir.
Yes, sir.
So total charge is a what? -12. It is there. Now I go for this. This is Fe +3. So if this I'll multiply with 4, can I say total charge is a +12?
Yes, sir.
So here total charge is a +12. Here total charge is a -12, and therefore this I will remove. This I will remove. This is Prussian. This is Prussian blue. How we are getting Prussian blue? When FeCl3 called as a ferric chloride is reacting with potassium ferrocyanide, then we are getting the water Prussian blue. If this one copied, let me know. So Prussian blue color we are getting only when this one and this one are reacting together.
Done, sir.
Completed.
Now, once you have done, now I go for the question. Deliberately, this ABCD I have explained you because unless until you are not having idea how the Prussian blue is formed, you won't enjoy the beauty of the question. Now in the question diagram, they have not given. I am giving you diagram, it is there. How in the question, how in the examination question comes? Question comes in this way. This is compartment A, this is compartment B, and this is our semi-permeable membrane, it is there. In this 0.01 m FeCl3, it is there. In this case, it is a 0.005 m, it is K4 FeCN6, it is there. So definitely this case and this case concentration is not same. If concentration is not same, osmosis is occurring, osmosis is not occurring.
Will occur.
Yes, osmosis occurs. Osmosis occurs. Yes, osmosis is occurring. Yes, osmosis occurs. I will write here, osmosis occurs. Because concentration is not same, and that is the reason why osmosis is occurring. Now question is asked in this way. And very carefully the solution. Once I have mentioned M and the M means it is solution, question is asked in this way. Blue color is formed. Blue color is formed in compartment A. Blue color is formed in compartment B. Is formed in both compartments, in both A and B. Blue color is not formed. Blue color is not formed in any compartment. Blue color is not formed in any compartment. What is the answer and why? What is the answer and why? Answer is D option. Blue color is not formed in any compartment. Can anyone tell me blue color is not forming in any compartment? Why?
It allows only solvent molecule.
That's correct. That's correct. Semi-permeable membrane, when this one and this one will react, then only you will get blue color. Semi-permeable membrane does not allow this and this to react. Semi-permeable membrane is allowing only solvent molecule. Solvent is the water. Water and water reacting does not give blue color formation. Water and water does not form blue color formation. So, right reason. Shall I start? Reason?
Yes, sir.
SPM, semi-permeable membrane, right? SPM does not allows mixing of FeCl3. Does not allows mixing of FeCl3 and K4FeCl6. Does not allows mixing of FeCl3 and K4FeCl6 and K4FeCl6. K4FeCl6.
Alvin and the Chipmunks. She could be a corset on.
Or
Yes, sir.
now, till now I have given you osmosis. Now I'll come for the actual topic. Actual topic is osmotic pressure. Again, this I'll use the word of the botany only. In the botany, anywhere you have read the word hydrostatic pressure?
Yes, sir.
Maybe in the botany, maybe in the physics. Yes. So whatever the hydrostatic pressure you have read, maybe in the botany. Definitely, I'm sure in botany you might have read, or maybe in the physics, same hydrostatic pressure. Now I'm going for. I don't know where you have read, what you have read, but I remember very well in my 12th class, my sir has taught the difference between the hydrostatic pressure and turgor pressure. Hydrostatic pressure and turgor pressure. Hydrostatic pressure and turgor pressure both are not same. Because of the turgor pressure only, Mimosa pudica, it is there, touch me not. Because of that only the leaves are getting closed. You're having idea?
Yes, sir.
So Mimosa pudica or touch me not, or in Hindi it is called chui mui, chua margai. It's called chui mui, or in some books it is called lajvanti. It is getting ashamed of and closing her. That is called as a what? A lajvanti. It is there. So maybe lajvanti, maybe chui mui, maybe touch me not, or technical name Mimosa pudica. In that, as soon as you touch the leaf, turgor pressure comes in picture, and because of that closing of the water, leaf is taking place. So here I'm not going for the turgor pressure of the botany. Here I'm going for the water hydrostatic pressure. So I'll go for the point number 2, osmotic pressure. So point number 1, I have gone for the osmosis. Now I'm going for the osmotic pressure. This is a trough. In this trough, this is inverted thistle funnel. The mouth of the thistle funnel is covered by SPM. It is your semi-permeable membrane. It is there. This is the solvent. And in this you are having solution. In this you are having solution. So can I say due to osmosis, this is the flow?
Yes, sir.
Yes, sir.
Osmosis means always solvent will move from pure solvent side to the solution side, from pure solvent side to the water solution side through semi-permeable membrane. So because of the osmosis, solvent molecules are moving inside this thistle funnel. So when they are moving inside this thistle funnel, capillary action takes place, and because of the capillary action, here water level is rising. Here water level is rising. Earlier this was the water level. Now this is the water level. It is there, and this height is h, and this height is nothing but what? H. It is there. And then from the physics you know very well, rho, it is nothing but pressure, or better say, I'll say P. P is nothing but pressure, is nothing but rho GH. What is rho? Rho is nothing but density. G is nothing but acceleration due to gravity. H is nothing but the height of this column. It is there. And this pressure is nothing but our hydrostatic pressure. First you draw the diagram and then I'll give you the statement. Hydrostatic pressure.
Completed, sir.
So,
Then write statement. And make diagram as a A point. This complete as a point, point number A. Now go for B point. The hydrostatic pressure developed. The hydrostatic pressure developed on the dilute solution. This is dilute solution. The hydrostatic pressure developed on the dilute solution. At equilibrium state. Due to inflow of solvent. When the solution is separated from solvent, when the solution is separated from solvent by semi-permeable membrane, by semi-permeable membrane is called osmotic pressure. By semi-permeable membrane is called osmotic pressure. Is called osmotic pressure. It's called osmotic pressure. Now I'll stop here only. Rest I'll go only Monday after discussion of the question paper. After discussion of the question paper, then I'll go for the continuation. I'll go for the continuation. And still I'm asking you, still you are having 7 minutes are left over. If any doubt you are having in tomorrow's Sunday's paper from the test portion, you can ask. When I started the class, strength was 74, 55, 53, then 74, and now it is 63. So from this, it's very clear that although class is going on and the members are going on withdrawing, and this openly I'll share with you better. Openly I'll share with you. Keep this fact in the mind. This thing is not happening in elite section. You ask your friends. You ask your friends. If in the elite strength is a 40, 39 or 38 members will guarantee come. 2 members are not coming because of health issues. And in between the class connectivity issue, they will never get. If getting once in a blue moon, in a month one time, in a 3 months one time, they're getting. That is the reason why getting high marks. Why high marks? Whatever the teacher is teaching for 1 hour, we are listening properly. And what is our problem? Our problem is that we're coming 10 minutes late. In between, we are having connectivity issues are there. Half an hour before we are withdrawing, coming 15 minutes late. Half an hour before we are withdrawing, 45 minutes over. For the 15 minutes, whatever we are there in the class, in that also our connectivity issues problem we are having. Then how you will get marks? How? Won't get. If you listen the class, you'll understand. If every time you are having connectivity issues when you are new in the first year, 10th class you have passed, correct? Then you are giving answer, it is okay because last year Corona was new to everyone and therefore online platform was new to you also, new to us also. It was new for both the people. That time connectivity issue, no one has told anything to you. You are coming half an hour late, coming 45 minutes late, but neither myself or anyone, we have not told you anything. We used to take you. But now still if you are coming and saying connectivity issue, it is there, current issue, it is there, it's a matter of concern. It's a matter of concern. State government is cancelling examinations. CBSE is cancelling examination. NTA has never told they'll cancel examination better. NTA has never told they'll conduct examination. If not in the month of August, September. If not September, October. If not October, November, they'll conduct exam, they won't cancel. So if exam they won't cancel, preparation is required, not required. It is required. Tell me, you people are better paying fee or not?
Thanks.
Then, if paying fee, imagine paying fee, not attending classes. Paying fee, not listening classes. What is the fun? What is the fun? That much extra money you are having, that much free money you are having, that going on paying money. Right? In this Corona, 50% of the India lost their job. 50% of the India lost their job. Those who are there in the job getting half salary. Those they are running business, 25% business only. Yes. So when your parents are getting money, whatever the job they are doing, I'm not bothered regarding that. It's hard-earned money. Morning to evening, they are working, getting half salary. Morning to evening, they are working, getting 25% only in the business. Earlier, they used to get 100%. Earlier, full salary. But not 25% business, 30% business, 50% business, 50% salary. But same amount of fee they are paying now. You can think of how much active you have to be there. How much active you have to be there, na? When parents are doing so much hard work and giving money to us for our education, and if they're not utilizing it, in Hindi, if I talk in Hindi, my mother tongue, पाप लगेगा तुम सबको. Yes. And that is the reason why always I'll be so much active in the class and very much punctual in the class. I am also having same feeling. If I won't take classes properly, if I won't come properly in the time, मुझे भी पाप लगेगा. Yes, मुझे ही पाप लगेगा. And earlier also I've shared with you in Hindi, better say Urdu language, halal ki खाऊंगा, haram ki nahi खाऊंगा. I don't want any 1 paisa extra from the anyone. No. No means no. Only from my hard-earned money I'll eat and my family will eat. Yes. And that is the reason why I am so punctual in the class and so much towards the class. And same thing I'm expecting from you. Yes, same thing from you. Because free money, no one can digest, whether yourself, myself, no one can digest free money. No. If I am not teaching you, if I am not sincere towards my job, then definitely the free money, if I'll take, the free money now for me problem is not there. That free money is going to harm me and my family indirectly. And definitely as a guardian of my family, what I want, my family gets spoiled or not get spoiled? Tell me.
Not good.
So easily I don't want that blood money. Don't want. Same thing for you. Same thing for you. No, sir, online classes are boring. Yes, it's boring. I'm telling you it's boring. Any other alternatives there?
No, sir.
No. No. If really alternate it is there and Sri Chaitanya is conducting online classes, then it's okay. Then you can pinpoint. No, sir, other alternatives there na. Physical classes you can conduct na. But that probability, that chance is not there. When that chance it is not there, we lecturers are coming without wasting time and teaching. And if the kids are not coming or if they're coming late because of some known or the other reasons, then what is the use better? What is the use? What is the use? In Hyderabad or in Telangana, in the Andhra, one phrase I have learned from my friends. Operation successful, patient died. Operation successful, patient died. Same thing. Classes running, not running. Lecturers taking classes, not taking classes. Qualified for the need, not qualified. That is called as a operation successful, patient died. Don't go for making this phrase correct. This phrase is not having any meaning. When my friends have told me first time, I asked them, how if operation is successful, patient has died? They had told me, no, you think of Sanjay. And the same thing. Sri Chaitanya is working here, college is working very properly. Lecturers are taking classes. You qualified in the need? No, not qualified. This is the meaning. Operation successful and patient died. No. When such a hard work college is making us to do, college is making us to do such a hard work. So definitely we too will make you to do hard work. Do hard work. Just one thing remember, beta. Few things remember. Don't care lecturers, problem is not there. Don't care God, no one has seen. Don't care others, not a problem. But don't fool yourself and don't bluff your parents. Your parents are your own, no? Okay, I am secondary, college is secondary. Rest friends are secondary. Parents are on. Na? Don't bluff your parents. Don't mislead them. Don't give the wrong information to them. Don't give. Doing a lot of hard work. Doing a lot of hard work and getting money. And don't fool yourself. You fool Sanjay Singh, you fool Rahim, correct problem is not there. Fool the parents, fool God. Don't fool yourself. The small things are there. Therefore, I thought 5 minutes I should motivate you. I should tell the reality. That is the reason why this 5 minutes time I have taken. Because sometimes reality I have to show you. Reality is a bitter. That is truth. Because truth is always bitter. Truth is always bitter. So let us meet on Monday for the paper discussion. And after paper discussion, I'll go for the coming topic. That is this continuation topic, osmotic pressure. All the best for the examination. Thank you.
Thank
Thank
you
you very much, sir.
Thank you, Vita.
Thank you, sir.
Thank you, Vita. Thank you.